Good. No, it was not ranch. I can tell you. I think it's Thousand Island. Not incredibly good. You know, because I've had so many business. Yeah, not quite as loopy and biscuit.
And we can check with Daniel, man, happy to see you again. Hey, how are you, sir? Things. I remember the last and you know somebody. Yeah. Hello.
Nice to meet you.
That was the last one.
There you go. Smart.
Well, welcome everyone. Welcome to GDG Dallas. This is our July 2022 meetup. Happy to see so many people in person. This is awesome. A lot of people are excited about Firebase. Next slide. I'm one of your organizers. Reed is our lead organizer. Stacy unfortunately couldn't be here, and is Joaquin online?
He is not.
Gotcha. Joaquin is unfortunately on sick. But so thanks to Bottle Rocket for sponsoring the Zoom. So for those people joining in online, including our speaker, that's how we're able to have this sort of hybrid environment. So thanks to Bottle Rocket. They are hiring. So all these roles are open as of right now. Talk to Luke about details or applying for those roles. Thanks to the Dallas Space, they are providing this space for us to meet in person, which is awesome. Zoom was fun, but it's nice to actually gather in person and get to see faces and talk to people. So we are right here. If you go back out, there's the way that you came in. The bathrooms are kind of over there on that other corner on the other side of the Pride Flag mural. We have a website, gdgdallas.com. You can go there to see all of our new events, see anything upcoming. We also have our website through Debbie. All of our events will also be posted there. We also have our Meetup site. That's how the majority of people find us. Meetup.com/gdgdallas. You can see all of our events and RSVP on there. We also have a Slack group, gdgdallas.slack.com. So feel free to visit that second link. You can get invited and get talking to other people about software development and about Google. We also have a YouTube channel, so we do upload all these meetups afterwards on our YouTube channel.
Live
stream. Yeah, we're live streaming on YouTube too. But yeah, you can go see last month's meetup about Android UI components. You can also see me awkwardly giving the announcements first time here, because normally does that. So we have all of our social media sites here. We're on Instagram, we're on Twitter. No TikTok as yet. Thank you applicants for anyone wants to volunteer to manage our TikTok account.
The minute-long code tutorial.
Yeah, there we go. So our September meetup. So right now we're not planning on having an August meetup because we're going to have one September 1st, since they're kind of close together. But really excited about this one. Mark Scheel, Google developer expert. He's going to be doing a talk on voice interaction in Google Cloud. So those who all want to join either on Zoom or in person, we'll have that September 1st.
And the plan is for him to be here.
Gotcha. Okay.
So,
yeah.
Still working out all the details, but hopefully he will actually be in the room speaking, traveling in from Denver, is where he normally resides.
Fingers crossed. Awesome. We love hearing people from the community speak. So if y'all have anything that you're learning or any topics or ideas, I already heard some conversation about people who've worked with Firebase before or things like that. Or after this talk, if you go build something cool in Firebase that you want to share, feel free to fill out this form. We'd love to hear from y'all and hear y'all speak. And usually we'll also ask if anybody has any announcements about the community, maybe a hackathon that's going on, or any other meetups that people are going to or are interested in. So we'll give a couple of minutes. If anyone has announcements, raise your hand.
Anyone, it's a hiring. Okay, so I'm a software engineer for my company, Young Brands, parent company, Taco Bell, Pizza Hut, KFC. We're hiring mid to senior level React engineers, Android, QA, SRE. So if anybody's on the market, what you're talking about, awesome.
And also, also talking
Senior engineer, awesome. We have a lot of opportunities for anyone.
Hey, who wants a tour of Makerspace afterwards? It's 36,000 square feet of all kinds of geeky stuff and machines and whatever.
There's
We'll do this afterwards.
a lot of things here.
So Steve, if you want them to just come talk to you afterwards, you kind of do it maybe 5-10 minutes after we kind of wrap up.
Yeah.
Okay. We've done a couple of those in the past, and they've always been real popular. It's kind of cool to see a makerspace if you haven't ever been to one.
I just check the Meetup page, let them know it's there. And again, once we're done with the live stream on YouTube, we'll have that uploaded as a video. So if there's something that you forgot or a section you want to go back and look on, just feel free to check out our YouTube page and see what other meetups we've had in the past. Awesome. Now it's time for our feature presentation. Our speaker, Andrea Wu. She works for Google, and she spends most of her day teaching developers how to make their lives easier with Firebase. She also does a lot of advocacy for diversifying the tech industry. She teaches and mentors for various education equality efforts across Google. She also works with nonprofits. And when the brain is too tired from all the meaningful work she's doing, she escapes to adventures outdoors. She takes photos with a mirrorless camera and writes on her personal blogs. So without further ado, Andrea Wu.
Hi, everyone. Can you all see my screen?
No, not quite, almost.
It says start sharing.
So it's building apps with Firebase or building apps
Yes.
using Firebase?
Yes.
Okay.
Yeah. Great.
You wanna-
Awesome. So yeah, I'm Andrea, and I've been working on the Firebase team for almost 4 years. It'll be 4 years next month, actually. So I first started out as a software engineer on the team for about 3 years, and now I'm currently a developer relations engineer. So I'm going to talk about how you can use Firebase to build an app from scratch. So if you've never, okay, so this is what I'm going to talk about today. I'm going to briefly introduce what Firebase is, and then talk about how to use Firebase in the context of building an app. So we're going to start with, what is Firebase? Firebase is Google's client-side app development platform, and it integrates with a lot of other Google tools, such as analytics and ads. And as it's part of Google Cloud Platform and built on Google infrastructure, it's also designed to kind of automatically scale. Yeah, so Firebase has a lot of support for different types of platforms, including, whoa, my slides did something funny there and did not do what I thought it was going to do. Okay, well, this is supposed to show all the platforms that we support, but since it's not showing, I'll just tell you what they are. We have support for iOS, Objective-C, and Swift, Android, Kotlin, and Java, web, JavaScript and TypeScript, C++, Unity, and Flutter. All right. So Firebase is a suite of almost 20 different products, and these are the categories that we like to think about to make sense of all of the products that we have. So Firebase is intended to help you through the life cycle of developing apps, which typically goes something like this. You probably have a great idea that you're really excited about that you want to build, and the first column of products will help you build apps. A lot of these have to deal with infrastructure and help you kind of build out your app so that you can concentrate on the meat of your app and not need to kind of deal with these kind of infrastructure things. We'll talk about a lot of those products today. So after your app is built and deployed, you can monitor how it's doing in terms of performance using the second column, or like the orange column of products, to help you improve your app quality. And once that's done, your app will hopefully reach a stable state where you'll probably start thinking about how to get more users and how to retain the users you already have. So that's kind of the last set of products on the right, intended to help you grow your app. And this might seem like an overwhelmingly large number of products, but don't worry, you can pick and choose which ones you want to use. You definitely don't need to use all of them at once. And the best part, I think, about Firebase is that all you have to do is install the Firebase SDK for whatever product or products you want to use. And you can just write a few lines of code most of the time, and you'll have the functionality of that product. Yeah. All right, so now that we know, sort of, hopefully, what Firebase is, let's talk about using it to build out a new app. So before we do that, I'm going to talk a bit about what our app is trying to do. So we're going to build an expense tracker. And so as a person who really cares about how I'm spending my money, I really want to track my expenses. And what I actually do now, this is not me making things up. I have a spreadsheet of my expenses, and I look at my receipt and manually enter information like the date, the vendor, what I got, how much amount or how much I paid for it. And this is fine until this happens. Having lots of expenses because I procrastinated and let my expenses pile up, or I went on a business trip and have a lot of expenses from the lifts and the meals and all of that stuff. On top of flights and hotel expenses. So it becomes quite painful and tedious to manually enter all of this data. And in large quantities, it's just not really that great of an experience to have to manually input all of this information for all of these receipts. So how can we make that better? Well, instead of having to manually type in the expense data for these receipts that I'm kind of keeping around anyway, I'm going to make an app to enable users to conveniently scan their receipts, and the app will automatically extract the relevant information from those receipts. So that way the app does all the work, and all that the user needs to do is upload a receipt image, and it can send the extracted information to the user for verification. And so the user no longer needs to do this manual work other than taking a picture of the receipt, which is a lot better than needing to type in all of the fields. So what are our app requirements? Well, first, we want to enable users to upload images either by taking a photo through their camera or by choosing an image that they already have on their phone. Then our app needs to find and extract the text, and we'll want to scan the receipt to parse for things like the date, the vendor, what they got, and the amount spent. And finally, we'll relay what we found back to the user because we need them to confirm that the information we extracted is correct. And hopefully we did a good job with the scanning and it's accurate, because if we did a bad job, then this isn't really a confirmation step, and they'll probably have to kind of input all the information manually again. So hopefully our app works properly. Yeah. Oops. All right. So diving a little bit deeper into what we want our app to look like, these are some of the needs. So we want to be able to securely upload our receipt images. We want to be able to store these receipt images and extract the text, and do some image processing on the uploaded receipts. So all of this sounds quite complicated, but let's see how we can accomplish all of this. So the first thing we said we need is secure image upload, which means we need users to be able to sign in. And generally, we probably don't want to spend a lot of time trying to build a logging in system. And it probably also be quite tricky to try to get the security of it correct on the first try, and also to try to scale the system eventually. And as a user of a lot of apps myself, I know that I don't really enjoy creating a new account for every single app that I use, because it gets pretty repetitive to set up an account with my first name, my last name, email, birthday, the name of the street I grew up on, and all that stuff. And then I have to remember my password, which I probably won't be able to do because, well, we're supposedly using different passwords for all the millions of accounts that we have. So it'd be really nice to not need to create a new account just to use this app. So how are we going to do that? Well, Firebase Authentication can help us solve a lot of those problems. It provides identity as a service, which means it lets you know who your user is. It also provides a rules system that lets you grant or deny access to resources in other Firebase products like Firestore and storage. And it's also ready to use out of the box. And it gives some advanced functionalities like email verification and account linking. So regarding my concern about not wanting to create a new account, Firebase Auth works with a lot of third-party identity providers, including Google, Facebook, Twitter, GitHub, and others. And once users sign in with one of these services, we assign that user a record within Firebase's system. And that basically includes a unique user ID and a signed web token, so that you have a consistent representation of your users and one that you can use against both Firebase's services and your own custom servers, no matter how they decide to sign in. So let's take a look at what the code will look like if we wanted to allow our users to sign in with Google. So assuming we already created a Firebase project and injected and installed the correct Firebase dependencies, we can handle authentication with just a few lines of code. And you can find all the code that I'm going to show you today in our Firebase documentation. So first here, as shown on the screen, we are going to create an instance of the Google provider object, which basically says we want to use Google to sign in. And if you wanted to use Facebook, Twitter, GitHub, or any of the other third-party providers that we support, you can use those respective providers here. So next, let's actually make the user authenticate. There's two ways to do this. We can either open a pop-up window or redirect them to a sign-in page. And what's shown here is we're going to show the user a sign-up, a pop-up for them to sign in. Yeah, we're going to pass in this provider, which is basically saying use Firebase Auth to sign in with a pop-up using the Google provider. And this auth variable here is basically the Firebase authentication instance that you just basically call from a Firebase authentication function. So provided that we get the result back, if the user signed in successfully, then we'll get the user information and we can get the user from doing result.user. And if there's an error, we can handle the errors below that. Right. So let's say we did want to give users the option to create an account using usernames and passwords. Firebase authentication can also do that, and it'll securely store and encrypt this information while also taking care of necessary tasks like generating password reset emails when users forget their password. And if you don't want to force users to memorize yet another email and password, and they don't want to sign in with any of the third-party providers either, Firebase Auth has support for phone number authentication, which allows your users to sign in simply by receiving a code through a text message. Great, so let's see how we'd be able to make a user create an account with email and password, as well as how to check whether a user has already logged into your app. So to create a user with email and password, we'd first have to make some pages for the user to create an account, as shown here. So assuming the users fill in both the username and the password, we can then use Firebase authentication code to create an account. So calling the create user with email and password function while passing in, again, the auth instance along with the email and password that hopefully they typed in from the previous screens, that'll result in either a successful creation of the account in which we'll get the user credential and we can get the user from that, or we'll get back an error. Let me show you what this looks like on Firebase console. I need to switch screens, so let me do that. All right, so this is Firebase console, which is basically where we can see information with regards to whatever products we're using. So authentication is in the build products. So if we click on that, we can see that we have a user signed in using email. This was created 2 years ago, and this is their unique ID that identifies this user. Okay, need to switch back to my slides. Let's see, oops. All right. So now let's pretend that the user had to log in again and they already have an account and wants to sign in. And let's say this is the screen for that. So they fill that out, and when they press submit, we'll call the sign in with email and password function and pass in the email and password from the screen before, and this will result in either a successful sign in or it'll fail. So let's talk about the succeeding case in both for creating a brand new account as well as for logging in. So anytime the authentication state changes, there's an on-auth state changed function that gets triggered. And if there's a user that gets that comes back from calling this function, that means the user is signed in, and we can grab relevant information about this user as shown here. And if there's no user, then that means the user is not signed in. Cool. So now that we've seen how to write a few lines of code to sign in, create an account, and check if a user is already logged in, this sounds probably a lot easier than trying to write your own authentication system. And there's one last tidbit that I want to tell you all about, which is that even though we already didn't need to write a lot of code, you can write even less code because there's a library that provides a lot of these sign-in pages. It's called the Firebase UI library. So there's sign-in screens with multiple third-party sign-in buttons. There's a create new user screen, screens to reset and change passwords, and all of this stuff. So if that's not where you want to spend your development time, you can use this library, which handles all of these cases for you. And it's actually an open source library, so you can customize it as you would like to fit the look and feel of your own app. Great, so now that we've enabled users to sign in through some of these third-party identity providers or through creating an account, and we also know whether they're signed in or not, let's take a look at what we need to do next. So we'll need to enable them to upload receipts. So let's say we have a screen to show the user to upload the receipt, either by taking a photo of it or by choosing a file that already exists. Once they do that and upload it, we should store these somewhere. What do we need from our storage system? Well, we'd probably like it to be fast for uploading and for viewing receipts from anywhere. And we want it to work well even with spotty internet connections. And we might need to store a lot of receipts, and we don't necessarily have a bunch of people to keep an eye on usage and adjust our storage capacity. And lastly, we might have to consider working with a variety of image types. So luckily, cloud storage was designed with many of these concerns in mind. So it lets you store many image types. And on top of that, it lets you store and serve user-generated content like audio and video. And it's generally used for storing big blobs of data that you don't need to change often. To store a lot of receipts, the amount of storage will scale automatically, meaning that storage space will increase as you have more content, and it'll decrease as you delete content. You won't need someone sitting there manually managing the amount of space your app is taking up in storage. And to be fast from anywhere around the world, cloud storage has a global edge cache. Which means that if I just pulled up a receipt to look at it, storage is going to store that in a nearby cache. So if I want to see the same receipt again 5 minutes later, I'll probably be able to get that receipt image pretty quickly. Sometimes, like I was saying before, internet connection's not so great. We wouldn't want my receipt to be half uploaded and then dropped because my internet was spotty. And luckily, storage takes care of this and handles retrying and resuming my uploads and syncs whenever my phone gets back its internet. And after my receipt is uploaded, it can be shared with other users instantly. So this means that if my parents want to look at my receipts for whatever reason, they can look at it right after I upload it. But at the same time, I don't want to just let anyone be able to see my receipts. So there are security rules I can set to protect it using the same auth kind of security rules that I talked about earlier. So these rules can say who is allowed to read and write certain files in storage. All right, so let's take a look at some code to upload files. Let's say we have a file we want to upload. Firebase Storage supports files from JavaScript, file, and blob APIs, bytes, strings, base64 formatted strings, base64 URLs, and data URL strings. Where are we going to store it? Well, let's grab our storage bucket and create a root reference. And from there, we can create a child reference to the full path of the file with the file name. So now with this reference, we can upload it to cloud storage by calling upload bytes, which uploads JavaScript files, blobs, or bytes. And we'll pass in the file reference and the file itself, and the file will then get uploaded, and we can do any post-processing needed after it does so. So this is for uploading, again, JavaScript files or blobs or bytes. If we wanted to upload a string, whether that string is a normal string, a base64 formatted string, a base64 URL formatted string, or a data URL string, we can use the upload string function and pass in the reference, the string we want to store, as well as what type of string we're storing. All right, so now we've uploaded our receipts into storage. Next, we'll probably want to run some code to process that receipt. But we may not want to do all the processing on the client side, which in this case would be a phone. Why not? Well, once we write our top secret code to process those receipts, we probably don't want anyone to just be able to take it along with the data. Requests coming in from users' phones might be trying to steal that information. So we need something to help us with running code against our data securely. We also probably want both iOS and Android users to be able to use our app, but we may not want to duplicate code to process those receipts twice. It'd be a lot better if we could write the code once and have the code run instead of writing it once for iOS and deploying that to the App Store and writing it once for Android to deploy to the Play Store. And also, if we deployed the app separately, iOS users might get this awesome feature first, and Android users might get mad, and we definitely don't want that to happen. And lastly, remember we're looking to process our receipts, and we mentioned we'll need to run text recognition on those receipts, which we can imagine might be CPU intensive. And the last thing we want to do is run highly intensive code off of our users' devices, especially because it might drain a user's battery or cause it to be really slow. So Cloud Functions can let you run code in the cloud. It's in a secure environment, and you can write it once for both iOS and Android. So to run this code, you can trigger it based on platform events or a HTTP request on both platforms. And since it's running on the cloud off of the user's device, this won't be hard on their devices. And best of all, basically what this is doing is you're running backend code without managing any of your own servers. All right, so we know we're going to use functions to run our processing, but what are our functions actually going to do? Well, we need some machine learning to help us extract the numbers and information from the receipt. This is also known as optical character recognition, or OCR. And we want to get this automatically done. But I don't really know how to do machine learning. Machine learning is not a trivial task, and usually a team would need a data scientist or an ML expert to build and train these models. And in order to serve these models dynamically, we'd have to build up the infrastructure to also do that. And that's before we even write the client code to interact with the model and generate predictions. So this is typically a very involved and long task, which we may or may not have time or energy or resources to kind of deal with. Luckily, we can use machine learning to help us with that. So what is Firebase machine learning? We take some of Google's best machine learning models to help with different ML capabilities, depending on what features you're looking to add to your app. So it can recognize text or barcodes from an image, translate text to a different language, or identify important objects in a photo. And best part of this is you don't really need to know how machine learning works. You just call it the Google Cloud Vision and natural language APIs in your app, and you're basically more or less ready to go. And while these libraries can be useful in many situations, what do you do if you have machine learning needs that don't fall into one of these categories? Well, Firebase machine learning has custom model serving and auto ML vision edge that makes it easy for you to create and deploy custom ML solutions on your users' devices. So from all of these, we are going to use text recognition for our OCR feature. So now that we've used some machine learning to extract text from the uploaded receipts, what's next? After we get that text back, we need to put it somewhere in a secure environment. There will probably be a lot of extracted text, and we want this text to be quickly accessible from anywhere in the world. So where should we put it? Cloud Firestore. So as a reminder, earlier we talked about storage, which we use to store the receipt images. Storage is usually used to store big chunks of data like images, audio, and video. Cloud Firestore, on the other hand, is a NoSQL database where you can store data like strings, numbers, and whatever else your app requires. And Firestore is used more for structured data that you might be changing often. So while we stored our receipt images in Firebase storage, the processed text that we get back from Firebase machine learning is going to be stored in Firestore. So very similar to storage, Firestore also integrates with Firebase Auth and security rules. So clients can talk to the database directly, but you can still make sure they only get access to the documents that they're supposed to see or modify. So let's dive a bit deeper on how Cloud Firestore is structured and how to use it. So it's a document model database, which means that all of your data is stored in documents and collections. You can think of a document as something like a dictionary or a hash table. It has a set of key value pairs, which we refer to as fields, and the values here can be a number of different types, anything from strings to numbers to binary values to JSON-y objects called maps. So here we have a document containing the fields we saw on the previous slide. Each of these documents is stored in a collection. Documents cannot contain other documents, but they can point to collections that contain other documents, which can point to sub-collections, and so on. So in our example, each document will contain information from one uploaded receipts. So here are some examples of what that might look like. Each receipt document contains some values, including the date, the amount, the vendor, the item, and whether the user has verified these details yet. All of these will go into one collection. So with code, it'll look like this. We'll first get our Firestore instance, and then we'll add a document. Whoops. We'll add a document using add doc. And the first argument is which collection we're going to put this document in. So in our instance, we're going to put it in a collection named receipts. And the collection function always takes the instance of Firestore as the first argument. What are we trying to add to each document in the collection? Well, we want to add the key value pairs that we see in this receipt. We also want to say whose receipt it is, and we'll do that by using the user ID provided by Firebase Authentication earlier. And when that document is successfully added, we can do something with that. If there's an error, we can handle that as well. I'm going to switch again back to Firebase console so that you can see what this looks like in the console. Okay, let me find my Zoom window. All right. Right, so Firestore is also under the build category. Then it's this one. And so here we can see we have the receipts collection. This is the document where we just added our receipt information. All right, me switch back. All right. So now that we've added the extracted text for our expense tracking app into our database, how do we get that data out of the database in order to send that information to the user to ask them to verify the amount? Since we want to get not all of the receipts that exist in this collection, but instead only want a specific user's receipts, we'll write a query to do that. So there's a query function where the first argument is again where the collection to the reference that we want to get it from, and and then the other arguments to this query function will be our actual queries. So we can use where, which takes a field to filter on, a comparison operator, and a value. So in our case, we want to get all of the receipts where the user ID equals the function's UID. We also want to get the documents that the user hasn't verified. So we'll add another query on top of that where we check for that. So this is basically going to get all the documents in the receipts collection where the user ID equals whatever users we're trying to get, and they have not verified that receipt yet. So with that query, we can use the getDocs function to get the documents that satisfy this query from the receipts collection. And when we get that back, we can then loop through each of the documents and send the information to the user to verify. And as a side note, in Firebase, we actually have two database products. One is Cloud Firestore, which we just talked about, and the other one is Real-Time Database, which is an older database product, but is still around. So Cloud Firestore is generally a better option unless you need to structure your data in a JSON tree instead. The link here below describes more differences between the two, but in general, if you're not quite sure, Cloud Firestore is probably the answer. All right, so now that we've extracted text by deploying functions that runs our text recognition in machine learning and stores that information in Firestore, what comes next? Well, we want to notify our users that we have their values, and we'll ask them to confirm those values. How do we do that? Let's send a push notification by using Firebase Cloud Messaging to tell users to confirm their receipt amounts. So cloud messaging is powerful and scalable, and it can deliver hundreds of billions of messages per day, with most of them delivered in less than 200 milliseconds. So our users trying to upload receipts probably all use different types of phones. Thankfully, we don't have to invent our own notification system for each phone or each device, because cloud messaging can deliver notifications to anyone using Android, iOS, and even the web. Cloud messaging doesn't need us to track what kind of devices our users are using, and we also don't need to set up different service calls to different devices. Firebase will automatically do that for us. And lastly, we're not only limited to using this to remind users to confirm their receipt amounts, we can also announce new features we're launching. For other apps that isn't this expense tracker, we can notify users for things like letting them know their last message was responded to, or sending out discount offers or reminders about events. All right, so now we've notified our user to confirm their receipt amount. We'll store this response back into Firestore and basically flip that verified Boolean to true now that they've confirmed it. So now that we've built our app, it's just sitting on our laptop or perhaps in GitHub. If we built this using mobile, so like Android or iOS, which is most likely the chosen platform for this particular app, we'll eventually figure out how to put it on the Play Store or the App Store. If we build this on the web, we can use Firebase hosting to help us get it off our laptop and actually deploy it onto a website for people to use. So let's talk a bit about Firebase hosting. First and foremost, it's a really easy way to host your web apps. All you have to do is install the Firebase command line tool and write a single command, Firebase deploy. And from there, Firebase hosting provisions a HTTPS certification, which guarantees security and deploys your assets to an origin server that will serve your content through a global CDN. And if for any case you want to roll back your app, you can go to Firebase console and roll back from there with just one click of a button as well. So Firebase hosting has a global CDN, which stands for Content Distributed Network. And this means that there's a distributed set of servers holding your content. So whenever someone pulls up your page, the content is retrieved from a location as close to the user as possible. So for example, if we did not have a global CDN and only had one server in the US, someone halfway across the world trying to access our website might have to wait a bit for the page to load, which really isn't that great of an experience. With a global CDN, we have another server closer to that user, so accessing our website will be faster because the place to get the content from is physically closer. Sometimes we'll have to update our website after having deployed it once before, whether it's because we changed some content, added some features, or some other reason. When we do this to update and redeploy to Firebase hosting, it's atomic, meaning that all of the servers get updated with our new website and all the caches get purged. So this way, the user is guaranteed to get the latest version. And lastly, the heart of Firebase hosting is static, which means you're not using a backend system with your code, and typically means pure front-end JavaScript or front-end frameworks. For dynamic sites, you can combine Firebase hosting with Cloud Functions to run backend code and generate content on the server. Or if you don't want to use Cloud Functions with hosting for dynamic sites, you can use one of Google Cloud's products called Google App Engine to host dynamic sites. All right, so there we have it. Our app is built. So we've successfully built an app from beginning to end with full functionality. So we enabled users to log in via authentication, upload receipt images, which get stored in storage, trigger functions to do OCR using Firebase machine learning to extract details from the receipts, which then get stored in our Firestore database. And next, we run some more functions based on values being written into Firestore to automatically send a cloud message to a user to have them confirm their receipt amount. We even put it up on a website so people can start using it. We didn't have to write very much code to accomplish all of this functionality, yet here we are. So these are pretty much all the Firebase products that can help you build an app. And actually, cloud messaging is typically used to kind of help grow your app, but I tossed that in kind of as a bonus. So yay, that's pretty much all I have. Here are some resources for the materials that I covered today. The first one is a link to our Firebase website, and from there you can see an overview of all of our products in detail. And each product has a lot of documentation and guides you through that particular product. And as I mentioned before, all the code I showed you today is on our documentation somewhere. I pretty much just grabbed it straight from our documentation. The second link here is our official Firebase YouTube channel, where you may or may not see me on it, but it also shows and steps you through different Firebase use cases and helps you with specific products. And lastly, you can always use your favorite search engine to find more information about Firebase, as it's a pretty well-supported community. So thanks for attending. That's all I have, and I am happy to take questions.
Yeah. Hey, I have a question. On the topic of hosting, does Firebase support Docker?
Sorry, does it support what?
Something. Oh yeah. Does it support Docker? Docker.
No, I don't believe so.
I have a question.
Sure.
Yeah.
Okay, can you hear me?
Yes.
Yes. What would you say is the target audience for a Firebase user versus like Google Cloud platform? Because I've used GCP in the past, and it has cloud functions, it has data storage. So like, why would I choose Firebase versus GCP?
Yeah, that's a great question. So Firebase will kind of help you go through the app lifecycle. So it'll take you through building an app, and then once you there's a lot of products to help you build that app, as we saw today. And then there's once you launch it, there's a lot of products to help you kind of see how it's doing in terms of performance, monitor crashes, help you fix bugs, and then hopefully once your app is in a stable state, there's products there to help you kind of grow your users. Yeah, so you're right. There are a lot of our products are on GCP, but also a lot of our products are not on GCP. Yeah.
Thank you.
Of course.
I have one. Sure. So when you said that you are extracting, through APIs, right? So here API, you are extracting the images, right? So are you doing it on distributed cloud? Google distributed cloud, or how are you doing that? Page notes. How are you processing that? Are you leveraging Google distributed cloud? ADC?
Sorry, I can't quite hear you. Can you repeat your question?
Yeah, when you said that you are trying to extract, from the image, extract numerical from the image, right? Data from the image. So, say, suppose in naming area we have 100,000 users. So all of them use it at the same time. So are you leveraging Google Distributed Cloud anywhere, or how are you processing it?
Oh, your question is how are we processing that image? Yeah. So
like if 1,000 people hit it at the same time, how is that being handled?
Yeah.
if 1,000 people are trying to process the image at the same time, how is that being handled?
Yeah. From the same area, they're trying to use it. How is it being handled?
So if it's Firebase, it's consuming GCP, right?
Yeah.
And so
I'm asking if it is leveraging Google Distributed Cloud GDC in order to do that, or is it Google Edge? How is it at the back end? So I just wanted to know. So I leverage GCP in my day-to-day environment. So we I have a little concern on how they use it, how they try to leverage it, because based on that I can come up with some apps.
So it's about like distributed, kind of like
actually,
how well does it scale, basically?
how does it scale? How does it compute? So see, suppose a single person uploads the image. Okay, the app. It takes the data once. It goes to the the GCP environment of the customer, and then it scales it. But when in certain areas there are 100,000 users, all cannot hit at the same time. So Google came up with the concept of Google distributed computing. So each area would have different edge node. So the process based on that. So I wanted to know. So suppose if I wanted to scale, so are they going to leverage GDC? How are they going to do it?
is this
Okay, so the processing of images is happening on Cloud Functions, and Cloud Functions is running on servers that automatically scale. The functions are calling the Google Cloud Vision API to process those receipts. That is also running on Google servers, basically, and that is also designed to scale. Does that help answer your question?
Yeah. So I wanted to know if they are leveraging by GDC.
So yeah, the question is specifically, is it using GDC to scale, right?
Yeah.
That's basically like, is it using that technology underneath? But I don't.
Google distributed cloud.
Yeah, so Cloud Functions is built on top of GCP. And then it's calling the Google Cloud Vision API, which is also built on GCP.
GDC versus GCP. Lots of acronyms.
Yeah, like Yeah, I don't know. Like, I'm guessing it scales, but I don't know if it's using the same GDC scaling as what they allow. I would think that it
Actually, what
is.
GDP does is it aggregates the data. I mean, see, if 100,000 users are using it, it cannot send all the data to the website, right? So what GDC does is it aggregates the data and sends the anomaly first, and then the aggregated data next. So in that way, it does a batch processing, and anomaly would be a streaming, and other things would batch it. So in that way, say in GCP, what happens? Batch doesn't cost money, streaming costs it. So we leverage our, I mean, that's how we do processing and updating here.
Might be on the scope of it.
Yeah, that might be a little bit more of an advanced implementation question.
Well, I have a slightly related question, maybe. Is there any short-term, are there any short-term plans for maybe another class of cloud functions, perhaps some that are hot all the time and don't have full startup? Like so-called edge functions that we're starting to see in other places in the marketplace?
Sorry, what is your question?
Are there any future rollouts of other kinds of cloud functions coming in Firebase? Like the existing ones have cold start.
Not that I know of.
Okay, thank you.
I was curious about when you're talking about cloud store and you're having to create a file name for something before you upload it. Is that something that you just have to keep track of yourself, like when you generate these file names, or are you, and follow up to that, is there a way to just get a list of all the files that you've uploaded underneath a certain user account?
Yes. So your first question was, do you need to create a file name before you upload it? Yes. Can you get a list of all the files you've uploaded? Yes. This is on the documentation.
Okay. Any other questions? Cool. Well, thank you very much, Andrea. I think if I unpin, we've got you pinned on the big screen. Let me see, so you can see us. So we're over here. Everybody, thank you. We can see everybody. Hey. So big crowd, big turnout. Our biggest meetup since we've returned to having in-person meetups for sure. So thank you very much, Andrea, for telling us a little bit more about Firebase. Thanks everybody here for coming. We'll stick around a little bit and kind of, so we can all kind of mingle and chat. If you have other questions, we can kind of talk shop. But Andrea, thank you very much. Let's give her a round of applause. Thanks everybody who joined virtually and on the live stream. And hopefully we'll see you next time. Bye, Andrea.
This when we start talking about what we do.
Let's see, how do I stop the live stream?